episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome everybody again to another episode of our show with another truly fascinating guest who is helping to create a better tomorrow on many different fronts. Today we are going to be journeying back into this fascinating domain of hallucinogenic substances and their potential benefit in a variety of mental health disorders. We're also going to be going into a really interesting area and discussing some very unique intersections of the central nervous system and the immune system, and sort of the integrated connection to a range of psychiatric pathologies and ultimately potential interventions. We're honored today to be joined by Mike Wang, who is a neuropsychiatric researcher and adjunct teaching faculty in neuroscience at the Johns Hopkins Krieger School of Arts and Sciences. Mike is one of the youngest principal investigators at Johns Hopkins School of Medicine, currently leads a clinical trial examining how hallucinogenic levels of the over-the-counter cough remedy dextromethorphan might actually serve as one of the world's first rapid-acting oral antidepressants. Mike's work has been featured in academic journals like the American Journal of Psychiatry, as well as many popular outlets like Psychology Today and Vice. Mike received his graduate training in immunology at Johns Hopkins Bloomberg School of Public Health, studying rare viral encephalopathies and neuro-immune determinants of depressive disorders. Outside of his work in neuropsychiatry, Mike serves as an educational reform advocate and board member of the educational nonprofit makeLAB. He was also one of the founders of the S-ketamine clinic there at Johns Hopkins. Mike, thanks for taking the time to come on the show today.
Thanks. I appreciate you having me on.
Absolutely, absolutely. This is always an exciting set of topics. Typically we start things off just by handing our guest the floor for a little bit. Mike, if you could sort of take us back a little bit, introduce yourself, everything from where you grew up, how you developed this interest in medicine and psychiatry and neuropsychiatry, and a little bit of your journey to date. I think that'd be a great way to start things off.
Gotcha. Yeah. So the interest in finding a fix for suicide and depression runs very deep. I grew up in Palo Alto, California, which The Atlantic did a story about because it was essentially the child suicide capital of the US. It was so strange that the CDC actually set up shop in our high school trying to figure out what was going on because so many kids were killing themselves. And I had been surrounded by a lot of miserable people. You could almost guess that it was something in the water. But really, these guys, they would get hit by this horrible, it really looked physiological, this depression, and it would really never leave. It was like a cancer of the mind. Treatments never really worked. They'd kind of go up and down, up and down, up and down. And then I've had friends who have ended their lives. Beforehand, it was never really a matter of, oh, I love science. I wanted to be an animator. I grew up skateboarding, basically only skateboarding, and then, decided to get my act together. Well, actually, no, my parents forced me because that's what Chinese parents do. And basically took some classes, summer classes at Johns Hopkins. First time I enjoyed education, first time I had a good time not skateboarding, honestly, and it turned out it was in a neuroscience class. So the performance that I had was, I did not expect it. I was never good at science. And then I think I managed to impress enough professors there that despite having basically non-existent A's and B's, I managed to get into Johns Hopkins. So, getting into Johns Hopkins, that's kind of where this all started. It was interesting because with the Johns Hopkins neuroscience curriculum, a lot of their basic scientists are also clinicians. So you get that very interesting mix, and they really love to cross-pollinate between the undergraduate experience and the medical school. And basically there's this one very charismatic, interesting guy named Dr. Adam Kaplan who came in and had a talk, and he was talking about ketamine. And ketamine was this very strange, now beforehand it was kind of played up like, oh, you took one dose and then your depression disappeared forever. It's not like that. Right. But essentially it was strange. It was extremely subversive, and it caught my attention. And especially since people call it Special K, they call it horse tranquilizer. Now, how is it that this one drug is going to, people are saying that it's going to fix this suicide, this depression problem? It's an epidemic. It's just rising linearly every year. How is this? I just couldn't in my mind envision, say, one of my childhood friends taking something like ketamine, getting high, and then waking up the next day with the light back in his eyes, but little did I know in the clinic, while it will never cure your depression forever, it really does put the light back in people's eyes. And it's not because it feels good or that, oh man, they're just addicted to a drug anymore. So that was very interesting. So essentially, as punching way higher than I should have, being way too audacious, really stepping out of the chain of command, I basically harassed this Dr. Adam Kaplan for months, saying, hey, I want to get involved, I want to get involved, I want to get involved, not knowing anything about anything. And then he finally took me on. And basically, back then, ketamine was wonky. It wasn't, now it's the talk of the town, but beforehand it was just like, are you really going to do that? Are you really going to get people high who, in a population that's already with such a high morbidity with substance abuse? And is that really what you want to do? And my boss said, yeah, let's do it. So that's really how I got involved, how I really decided to invest myself in neuroscience, because beforehand I literally had my application ready to go to transfer into CalArts, because I was just did not think this was for me. But just being able to use these very, very strange drugs to do a very strange thing, very interesting. So depression, it's kind of this the psychic suffering. It is a disease of the mind. And if not to get too philosophical, but people say in the world of like philosophy of mind that the mind is this other substance that doesn't quite interact with the material world, and that whole substance dualism thing. But lo and behold, we have drugs that can reach out and can modify the mind and can fix all these things. And now all of a sudden we have ketamine, which is, for reasons still kind of unknown, it is essentially an on and off switch for depression. And I say this not because it is wholly effective, but compared to previous treatments, which are roughly 30% effective, and that's what we've been leaning on for 50, 60 years, this is an on and off switch. We don't know how it works, but guess what? We can take that switch. We kind of have an idea of the basic receptorology, the basic ways it interacts with cells at a fundamental level. Let's just move out from there and reverse engineer happiness, sadness, that sort of thing. And it's led to some very strange, very subversive conclusions about the mind and how we suffer. So that's basically how I got into ketamine research. It was really a matter of you've had many esteemed speakers as part of your series. They seem like many late career guys. For me, I'm very much I managed to punch my way into starting my own clinical trial, basically out of pure enthusiasm and dumb luck. So ultimately, that's where I got where I am today. So currently, the next steps are ketamine isn't the end all be all. It is still a controlled substance. The nasal spray, patients have told me burns like Mexican food and tastes like vomit. And you know, it can't be the only drug. So now we're looking at something else, and it just so happens that the thing that most mimics ketamine pharmacologically, and we've known this for decades, and nobody's touched this, known this for decades, the closest pharmacologically like sibling of ketamine is actually over-the-counter cough syrup, which funny enough is no better than honey, if not less good than honey for cough. So kind of makes you wonder, you know, why is this here? So that's kind of where I'm at.
No, it's a great introduction. It's a great background to everything we're going to be getting into, and it's funny because you mentioned sort of mechanisms, and you know, as we've discussed previously on other shows, when you get into some of these materials, let's say, they're not like your SSRI, right? They're not like your Prozac that do that one thing. These are much more shotgunish to the brain. They hit a lot of different receptors, and I mean, you can go into some of this. When you're looking at, so, you know, we talked about on previous shows things like Ibogaine, things like psilocybin, which, you know, fall into those that more psychedelic class. In the case of these substances that you're working with, the ketamine, the dextromethorphan, we're falling into sort of this dissociative class. I always talk about sort of, you know, Brad Pitt and Fight Club, all right? Something here, but it's not really there, but it's sort of that type of, if you do too much of it. Talk a little bit about what we know nowadays. I mean, obviously we don't know everything, but when we're talking about a ketamine or a DXM, what's going on receptor-wise in the brain? What do we know today?
Yeah, so we can, like, it's really important that we make this distinction between things like ketamine and things like psilocybin, or things like dextromethorphan and ketamine. We call them dissociatives versus your classic hallucinogens. So it's actually kind of interesting. They had originally, before they called these guys dissociatives, they called them psychotomimetics. Because it's going, supposedly, the big granddaddy of all of this was PCP, angel dust. That was one of the first anesthetics that people are playing around with, but unfortunately, sometimes patients would get agitated and very, to say the least, right? You know, stories about cannibalism and all that. I'm not sure how true that is, but essentially, these drugs were thought to induce psychosis, and they believed that so much that they actually were using things like PCP and ketamine to study schizophrenia, which kind of a dead end there, kind of strange. Low activity in that area, it's kind of making a resurgence, but they were kind of barking up the wrong tree. But basically, what it boils down to at the receptor level is that your classic hallucinogens hit serotonin. And they basically, every serotonin receptor under the sun, they grab onto that guy way harder than serotonin. They crank it up in ways that serotonin never could. And that's how you get all this, you know, very strange symphony of activity. Ibogaine, it's a little bit of a weird one. It works through the opioid system, supposedly. Still, jury's out on why that makes you, creates that similar altered sensorium. But in the case of ketamine, what it does, ketamine and dissociatives now that we call them, they block one of the fundamental on switches of the brain. So between neurons, classically, when one neuron wants to tell another neuron, one brain cell wants to tell another brain cell to fire, it sends this one thing called glutamate. Glutamate is just kind of the, you know, hey, wake up. So Glutamate classically hits two receptors. You have the AMPA receptor, and then you have the NMDA receptor. Those are the two on switches that glutamate hits, and those are just the bread and butter of the brain. For some reason, ketamine, it blocks these dissociatives. They block the NMDA receptor. They're NMDA receptor antagonists. The molecule literally just swims in and plugs the hole. Nothing can go in. Nothing can go in. And for some reason, it doesn't, when you think about it, how is it that a drug that just plugs up the hole for one of the main on switches of the brain, it doesn't throw you into a coma or anything like that, or turn your brain into soup. You're still very much awake, but all of a sudden you get this strange set of symptoms, dissociative symptoms, that are qualitatively, some people say they feel similar to psilocybin, but ultimately they're pretty different. One of the common things is they're called dissociatives because you feel like you're leaving your body. Yeah. So what does that mean? It turns out the brain has this constant updated model of your body. It has a little simulation of your body that it compares to what your body is actually doing to make sure everything is working properly. And for some reason, these dissociatives make that little model that your brain relies on, that virtual model, start really deviating from what's going on out here. So there are people have said that basically on ketamine or dextromethorphan, I've closed my eyes, laid, taken a nap, and then woken up and walked around my house, and then opened my eyes again and found myself still in bed. So these sorts of out-of-body experiences, some people feel as they're laying in their chair or whatever, that their body is twisting into, inflating or squeezing together, but you're all still there. So that's kind of the classic dissociative symptom. Dissociating can also refer to a feeling of separating from the world such that the world feels like a movie, or just this sort of, I'm just watching, and I'm actually an audience in a separate area, and everything is detached from me. What is all this? These are just robots, essentially. So that's kind of another dissociative effect too. Can be a little depressing for some people. And then there are things where all of a sudden things right in front of you, you will just have the sense that they are enormously far away from you. Even though you know that they're right there. But for some reason, the TV, say it's a TV, looks the same size, but you just have this sense that it is hundreds of feet, maybe a mile away, but it's right in front of you. So yeah, exactly. Yeah, it's really, so those are kind of what mark dissociative symptoms. And then at very high doses, you'll actually, because ultimately they were conceived as anesthetics, you will, with ketamine abuse, people call this the K-hole, where you, at very high doses, you essentially just jump into oblivion. You're just completely detached from reality and this just nothingness, and you're just floating. And we don't really do that. I don't think there's much therapeutic value in K-holing people for major depression, but it is interesting. And this is a very new area of exploration. It isn't just, wham, bam, and done, give them the drug, watch them in a clinic, and then send them out, but actually talk through with them traumas, emotions, life histories, with ketamine or dextromethorphan. One patient described dextromethorphan as putting your mind into developer mode, in that you sort of manage to separate yourself from the sort of machinations of everything that's going on, and evaluate them without being affected by them. And then, that sort of thing. Psychotherapy, that's one of the main things we're looking at with the group that's at Hopkins. It's Griffith's group that's known for psilocybin research, really advancing that. So really, that's the state of things. But if I were to sum up, go all the way back and sum up, the answer to your question, dissociatives, ketamine, and dextromethorphan, they work through binding a very different receptor, one of the on switches of your brain. And for some reason, rather than turning you off, they make you feel like you're leaving your body. And also, for some reason, they have a very neuroprotective and actually call it a neurotrophic, like a brain fertilizer effect.
Mm-hmm.
So that's the kind of gist there.
Very cool.
Yeah.
It's always wild hearing these phenomena. And as a joke to you offline, I mean, as a child of the 60s and 70s, I drank dextromethorphan. Everyone was like, "Oh, you don't want to take the codeine." It's like, "Oh, okay." So I don't know. I don't know if how dissociated I was back in the 70s, but whatever.
Yeah, it's funny. Yeah, that was part of the initial skepticism. Being somewhat of an unconventional, the way I kind of moved through academia was a little unconventional. But also trying to advance something like dextromethorphan. Yeah. Sometimes they won't say it, but you kind of say, you propose this, you're like, we're looking at dextromethorphan, we're looking at over-the-counter cough syrup as an alternative to ketamine. And you almost see it like a look in their eye, like, wait, like I've done this before. You're trying to give that to people? Yeah. They won't say it to you in person because it's a professional context, but they're like, you're insane. But the data informs this is, unfortunately a new movement in medicine, evidence-based medicine, but the data informs what we're doing, and the results preliminarily are, we can't push too hard, so we don't invoke the wrath of the FDA. Sure. But I will say that there is reason to look at this more. And more people should be looking at it. Yeah.
I mean, it's the ultimate, and as we say, repurposing nowadays. This is a hot word in the industry. So, talking a little more before we get into, so you have obviously done the ketamine clinic. You have this open label tolerance study with different doses of dextromethorphan study that you're doing. What is the once again going back to sort of the Ibogaine days from like 20 some odd years ago, back then it was no, you're going offshore, you're doing this in country X. Then there were smaller shops around that were kind of focused on this. We're talking Johns Hopkins here. This is no joke. So what's the mood like in just this general area in the clinical halls of power at a place like Hopkins nowadays? I mean, this is no joke anymore. This is medicine 101. What's the feel for whether it's ketamine, whether it's the
that's very funny. So pushing something as classically subversive as psilocybin or ketamine or dextromethorphan has highlighted a very interesting thing in academia. And it really brings people back down to earth, which is ultimately science, medicine, whatever. It's a social endeavor. What controls what gets advanced is the vibe, the zeitgeist, the commonly held opinions. This uprooted everything, right? So we had, you kind of had the natural. It's exactly how you expected in the beginning. It was that, okay, yes, the data inform what you're doing, but especially at very esteemed institutions, they're risk averse. Yeah. So you kind of do this, try not to draw too much attention to it. And you weren't really taken too seriously. It was just, hey, people thought that garlic was going to fix heart disease. Ketamine might just be the next garlic or something like that. Or say, something like Vioxx, like a targeted, extremely potent, theoretically perfect drug for X. Let's just wait. This doesn't sound too smart. People get addicted. it causes neurotoxicity, which ultimately isn't true. Let's just see what happens. So it really relied on the advancement of, actually people look at big pharma, at least in the popular mainstream, as some sort of money-making monster. But no, big pharma is integral in advancing the most. They are all business. They're not trying to find out one specific kinase in one little sea slug that's only found off the coast of Madagascar under a full moon. They're trying to fix disease. And that really, collaborations between pharma and places like Hopkins, like Yale, NYU, put out a couple studies that really, really strong, double-blinded, placebo-controlled, multi-center, big numbers, all that sort of thing. And they actually just locked it down and said, yes, there isn't much we know about abuse potential, and the protocols and all this are just untrodden ground. However, we have many legit people. This is a very legit looking study. Statistics look legit. Here's what the data say. If you don't like it, try to replicate this and tell us we're wrong. And essentially, as much as science is a social endeavor, thankfully, people are in science more swayed by numbers and data, maybe a little bit more swayed by numbers and data than in other enterprises. That sort of brought people around, and all of a sudden the people who are cautious were willing to not directly participate, but at least give us room to spread the gospel of ketamine, at least in a way. And then essentially what happened was, at least at Hopkins, it was funny actually. We at Hopkins have had unnaturally high success at getting with recruitment for these early ketamine studies compared to other places. And I think the reason why is that all of our clinicians they're scientists. They're told that we are clinician scientists, and they saw the data. And what happened was, psychiatry at Hopkins, everybody down to the residents knew about this stuff, and they started sending patients who they thought were good candidates to us. And all of a sudden, they were getting better. They come back to their maybe skeptical original psychiatrists, and all of a sudden, oh my God, I see it with my own eyes. This patient of mine who is taking this drug that is, a little wonky. The light is back in their eyes. They are, socializing again. Their vital senses is returning. There might be something going on here. So in that way, we sort of penetrated. And ultimately, the big essential stamp of approval was when the FDA finally approved the indication of esketamine for treatment-resistant depression. Finally, the seal of approval came. You didn't need to take sides anymore. Everybody in the clinic recognized, okay, this is now part of our quiver, our armament. And the way we kind of spin it is that esketamine, which is we do other rapid acting antidepressant drugs too, but essentially with these rapid acting antidepressants, yes, they kind of mess you up in the short term in that you get high or whatever, but see it like ECT. So ECT is electroconvulsive therapy. People get it all wrong. You think, One Flew Over the Cuckoo's Nest, they use it as punishment to turn your brain to mush or whatever. But it isn't like that. It is still considered one of the most effective treatments, but it is last line because you have to, anesthetize the patient, and they get memory issues sometimes. But ultimately, the protocol is, if you need results fast, you use these dissociative antidepressants, and maybe that way you can tide them over and put them on a normal regimen. But now this is an awkward phase. This is an extremely awkward phase in psychiatry right now, which is, okay, now we have the protocol for when people are really bad, or, they're in bad shape. And we now know what to do for the next 3 months with these dissociative drugs. We can get them back on their feet. All right, so now what? That 3 months later, do we keep doing it? Do we take them off because of the potential for, the abuse liability, and then try to get them on a conventional antidepressant? Or do they do this forever? And that is something where the culture is, there's no consensus yet. Are we going to live in a world where now we're going to be giving horse tranquilizer to people forever because they need it, because depression? Right. It really calls into question a lot of value systems that people might have. It's subversive, but really, psychotropics, strong psychotropics have been found in human history, in many, many, many different cultures. It's part and parcel with, I think, the human condition to, alter our worlds through what substances are around us, whether it's through ingesting them or turning them into concrete and building buildings, Yep. So that's kind of where we're at now. The social setting is changing for sure. Unfortunately, there's also, it's funny that you bring up the social part, because psychiatry as a whole is going through an upheaval. Psychiatry right now, there are two very different generations. One was trained essentially on the tail end of Freud. Freud and psychoanalysis and antidepressants kind of came into the fray as well, but ultimately these guys were not, the priority was just getting people better through pharmaceuticals, and then also for some reason there's psychoanalysis in the mix, and that was the tradition of psychiatry. But now it is a neuroscience discipline, like first and foremost. So the people who understand the neuroscience are far more okay with this. But the old guard, science is a social enterprise. There will be skeptics. There is, unfortunately, well, actually, you know what? I have to withhold judgment, but certain people are looking at the data, especially with dissociatives and ketamine. For some reason, these drugs also happen to bind to opiate receptors. Now, there are some people are saying, okay, now this is a reason not to employ this widely. These drugs are opiates. That's how they're working. Now, we can definitely, it is a viable avenue to explore it. That is most definitely something that we need to figure out. But for that to inform treatment and make doctors less likely to treat people who are in trouble because of preliminary data, that is dangerous. So that's kind of the social sphere. But I will tell you that, especially with something like dextromethorphan, where the stereotype is you have a bunch of bored teenagers who when they don't have access to weed, they use dextromethorphan, and abuse liability is high, and all of that. And that the reason why I'm running this trial is because there are no controlled, truly and this is still open label, right? This is still open label, but there has not been systematic controlled study of administering these drugs for this specific patient population of the depressed, and really characterizing what the course, their health outcomes are, their side effects, their mood, and all that. And nobody's really looked at it deliberately, and really tried to figure out, okay, do these people like it? Is there abuse liability? What are the symptoms for this population with these other concomitant antidepressant medications in their system? What's going to happen? So that's where we're at with dextromethorphan, and this is actually a really important crossroads, because ketamine cannot be the only one. It can't. It's just not ideal, because it's not orally bioavailable. You really need to, if you want to roll out a treatment implementation, is familiarity is crucial with implementation, and familiarity means oral formulations. And oral formulations are not there yet. The drugs that are out there, the new drugs that are out there that try to exploit this NMDA receptor, the results are mixed. However, with dextromethorphan, I will say that they are less mixed. They are less mixed.
Very cool.
Yeah.
Let's move on to the neuro-immune domain, or the crossover domain now, because this is another area that you're very active in, tying together. We discussed a bit in the past about how much we're learning about the connection of the immune system to the CNS. Had the opportunity to spend some time with Ruth Izaki over in Manchester, who, she's working on the connection between Alzheimer's plaques and herpes virus, did a show on sort of the gut first component in Parkinson's disease. So we need to get into sort of this crossover area. You're very focused on sort of looking at depression as a new neuroimmune phenomena as well.
Absolutely.
Take us a little on this journey and where you are.
The way I like to break it down to patients is that, so whenever anything is going wrong with your body, whether it is a bruise or a bad burrito or sunburn, the first thing to arrive to the scene is the immune system. They are the police, they are the fire department, they are the stewards of your body. And they're very good at what they do, and they have so many mechanisms for both messing things up and making things better, and they can get anywhere. So all of a sudden, you cannot study. So there was a problem with neuroscience and neurology, which is that we didn't quite pay the immune system much attention, because canonically, what they teach you in medical school or graduate school is that, the brain is an immune privileged site, which means that the immune system does not get into the brain, because the brain has its own microglia. So there are these cells, means like tiny glue cells, but really what they are is they're immune cells that activate. They're kind of like their own little police department in the brain. But it turns out there's constant traversal of the immune system through the brain and all that. And so basically now one of the first, there are two really lines of evidence that, depression is not just sadness and chemical imbalance and stress. It's not that. And before I go anywhere else, I'm about to make the case right now that depression is always an immune phenomenon, always. And fingers crossed I'm right in 20 years, but I'm confident enough to say that. Yeah, we'll see. Basically, so your immune system has your immune system can control your body. And what I mean by this is there's this thing called sickness behavior, where as soon as your immune system is really active, all of a sudden, everything else kind of slows down. You retreat, you want to stay in bed, you don't move, all of a sudden metabolism alters. The immune system has a way of taking charge and changing everything from your sleep habits to your cognition. And the sickness behavior, as they call it, is meant to supposedly, when you have bacterial pathogens or whatever, say your leg is chopped off and you're infected, that you don't move, you stay still so you can heal. That's how it was involved. And what they noticed is that sickness behavior and depression actually kind of look similar. Depression, you can't really move, you can't get out of bed. Oftentimes there are psychosomatic symptoms like aches and pains.
Sure.
You're sleepy, stuff like that, right? And then all of a sudden they found that certain immune interventions could cause depression. Something like if you have interferon therapy or so there was that. And then the other line of evidence was, and this is the most compelling, and this has to do with ketamine, is that when you give ketamine, this is the on switch, right? Now we're moving out from the on switch to see what exactly that on switch is attached to. Mm-hmm. When you give ketamine, you can actually predict, not everybody gets better on ketamine, because ultimately depression is a heterogeneous disease. It has many causes. The people who don't get better on ketamine, it turns out one of the best predictors of that is how inflamed are they in their blood beforehand. People with high levels of inflammatory markers that don't go down upon administration of ketamine, they're non-responders. And you actually see this immunosuppression and immunomodulation across essentially all antidepressants. It's that you actually watch one of the biggest things that people love to knock psychiatry and psychiatric disease, and that, oh, it's not objective, it's always clinically determined. You have no biomarkers. You have no biomarkers, you're not as cool as us in cardiology or whatever. Right. But we do have biomarkers now, inflammatory markers, and that is really strange. Why is it that inflammatory markers are what's up? And that actually helped answer a really strange third sort of line of exploration, was thanks to omics, looking at the whole genome, looking at just studying giant groups of people who have a disease, comparing people who have a disease, people who don't have a disease, and using very optimized lab protocols to sequence everything that's going on in their bodies, and comparing them with crazy advanced big data computing. When they did that with depression, originally they couldn't really find many signals at all. But the bigger the numbers got of people, of treatment groups, the more statistical power they got. They started finding, oh wait, why is it we're starting to get signals, but these people are depressed, the things that are altered in them, they're all immune genes. They're all genes that have to do with cells. So it's immune genes and cell organization, how cells kind of interact and stick together. And that really, we ultimately found out, relates to blood-brain barrier dysfunction, and essentially how the immune system relates to stress and how it might mess up the brain, and how that's different between, there's essentially a genetic difference, which isn't totally figured out, between those who are prone to depression and healthy people. So all of a sudden you have all these lines of evidence that show that the immune system is implicated. It is a biomarker, and of course, that should have been the response this entire time. The immune system is the steward of the brain, and all these sorts of separate lines of evidence are coming together. And lo and behold, we have in the past 10 years, we now have an on and off controller for depression for a lot of people. And it happens that the immune system is really involved. And one of the most exciting and almost upsetting advancements in that really drove home that immune system stuff really has to do with a lot of depression is that so ketamine is the big thing. It is the best way to, well, it is one of the best pharmacologic ways to treat depression across many different patient populations. Now, all of a sudden, they give an immune drug, an immunosuppressant drug, just once with ketamine, and they just jacked up the treatment response. They just cranked it up like 3 times. All of a sudden, people were getting way better. Rapamycin, systemic administration, rapamycin oral, 1 dose with ketamine, drastically increased the response rate for ketamine. So it is just, there's no way to really argue against it. And it's really strange, right? Because you think, okay, you have all these people, they get depressed, history of psychoanalysis, a lot of depression has to do with loss and trauma as children. How could you possibly tell me that because my father died and I couldn't get over it as a kid, that the reason why I'm depressed right now is because of my immune system? Riddle me that.
Yeah.
And there's actually a very easy way to do that now.
Yeah.
It's that the stress response is mediated through something called the hypothalamic pituitary adrenal axis, the HPA axis. And when you get a lot of stress, that sort of system that controls stress, it secretes something called cortisol, and cortisol is an immunosuppressant. And when you're stressed, the body interprets that as, okay, there's a lot of crazy stuff going on. Let's make sure that the immune system knows they're tracking, and so they can respond accordingly. Unfortunately, if you get way too stressed and you get way too much cortisol, it permanently alters epigenetic mechanisms having to do with immune response. And some people think even in the neuron growth itself. But ultimately, people suspect it's mediated through the immune system. And then finally, this actually goes back more to the big daddy of psychiatric illness, schizophrenia. But with schizophrenia, they find that, again, one of the biggest genetic contributors is immune. And also, one of the best ways to predict the onset of schizophrenia is actually whether the mom, while gestating the baby, got sick.
Okay.
And how do you explain? And that is that. So the immune system, immune signaling has a lot of contributions to, neural plasticity and growth and all that. But now that I've made my case, maybe it's better to kind of talk about interventions and how that might actually help cure depression, right? Because ultimately that's a big point in, your mission, right? You want to talk about the grand possibilities and basically I really believe that we have far bigger guns that are informed by far better research that are on their way to really help depression when really there's no help right now at all. 30% help, that's not that great. Ketamine, it's the first step. But the microbiome has an enormous contributor. Now, microbiome research is very difficult in that in order to track all these little bugs in your gut and quantify them takes a lot of statistical analysis and a lot of ways of interpreting the data, which vary between groups. So comparing data between studies is actually it's very problematic, and a lot of these studies don't have controls and all that. But really, all this microbiome research is showing that there's something going on. That's better than nothing. Something is going on, and the microbiome, it changes everything from how how drugs are processed, whether drugs even work.
Yep.
Depends on what's in your gut. The microbiome, some people, well, we know that one crazy example of a direct interaction between microbiome and the brain is that you have these models of disease like Alzheimer's or ALS,
Yep.
and in mice, and these animal models of disease, their genes are modified such that they are guaranteed to get the disease.
Mhm.
Now they find out that these mice, if they don't have a microbiome or they have an altered microbiome, when you alter it, they don't develop it. They don't develop the disease. So that's a pretty good argument that there might be a causative role. So in order to address depression, we need to see it as an immunological phenomenon, and B, the reason why the microbiome is involved and the reason why we need to look at the microbiome is it seems to affect everything. It is, I always like to say that, we like to think that there are three brains or one brain in the body, but I like to say that there's three. There's this brain, you have the immune system, which is another brain, and then you have the microbiome, which is, and the gut and the enteric nervous system. That's the third. And these guys all have varying agendas. They have very complex behaviors that are influenced by the environment. And there's a lot to be said in psychiatry with the microbiome. There needs to be more research. However, I would also caution against, interpreting any sort of single bacterium like, lactobacillus casei is going to fix depression because we fed yogurt to mice. And it's not there yet. However, the fact that it influences drug response, it has a direct line to the brain through the vagus nerve. The fact that the microbiome, for some reason, can actually improve outcomes with very complex psychiatric diseases like autism spectrum and schizophrenia. That when you look at the microbiome of these people, it is a better predictor of whether any given person has the disease. It is a better predictor than their genes. There must be something going on. So the next step right now, and the hope with our lab is that we're going to be able to, try to better implement these biomarkers for treatment response, FGF8 and IL-6 for day-to-day ketamine treatment. Because normally people think this is head in the clouds type stuff, and it's only going to be in research hospitals. But really, these tests, they can be IL-6. These are easy clinical tests, and they are able to determine whether you're going to respond to a drug or not, which is very important. This is personalized medicine. This is the next level. Why waste your time if it's not going to work? And we're implementing that, and that's very promising. And we're also trying to, the problem with the microbiome is that there are many different microbiomes. You have it on your skin, you have it in your lungs, but even in the gut, different parts, depending on the acidity, depending on what traverses that area, you're going to have different colonies of bacteria. So there's a little bit of heterogeneity in how much you can interpret the existing data. There needs to be a way to identify what are called keystone species in the gut, because the gut, the microbiome, it's kind of a society, and certain bugs, in a way, you can say have a say more than others. And that's where you can really draw the causative connections. We need to see how these keystone species affect treatment response as well. And these keystone species, we don't need to necessarily determine levels or do any sort of crazy diversity bioinformatics type stuff, just see what their presence is in the stool, see whether these keystone species vary with treatment response, and then all of a sudden we have serum biomarkers, we have stool biomarkers, and then we have just a far better, more informed approach for depression. So that's sort of where I really think it's going. And in order to further depression research, really, I think all neuropsychiatric researchers in depression need to be immunologists and gastroenterologists as well, because that's where you're going to really get the big money. Every intervention you do affects those systems. And yeah, that's where we're at. So essentially, that's my take on the future directions of things.
Yeah, it's very exciting. The word that goes to my mind is convergence, which is one of these hot terms nowadays. But it's really quite convergent. The CNS, the immune system, obviously, those 100 trillion or so members of the microbiome that hang out in us have a say, as you're saying. So yeah. This is really it. It's a quite elegant set of projects, and really like wishing you the best with all of this. It's really exciting. Do you want to say a couple minutes about what you do outside all? I mean, what's makeLAB all about?
Oh, sure, yeah. So though it seems disparate, but they're basically, my interest is the mind, and psychiatry looks at sickness of the mind. Education is the growth of the mind, and growth and sickness all inextricable. The way education works right now, it is essentially midway between an assembly line and a prison. And these skills are not applicable, and ultimately it's leading to consequences. We know that education status is a predictor for every sort of psychiatric illness, because if you have poor education, all sorts of bad things happen to you. Bad things, psychiatric illness, stressors. Yeah. So basically, another thing, my other side crusade, not a side project, side crusade is essentially trying to bring accountability to educators, and bring evidence-based practice, really easy evidence-based practice, which is don't teach through multiplication tables and all that. Teach through projects. Teach through projects so people have skills, so that when you release them out into the world, they don't feel immense despair and confusion and lose their minds. So makeLAB is it's kind of this initiative that our testing ground is actually the military education community. And we selected that because the military has they can proliferate complex things to all corners of the world, all sorts of bases quickly. And the military kids, military brats, they face a sort of very unique adverse educational challenge, which is a lack of continuity in education. So this is a really nice testing bed for project-based learning. And basically what we do is we have this we use implementation science to get these maker spaces. They're called maker spaces, places where people do essentially you can facilitate a lot of hands-on projects with rapid fabrication tools. We have an implementation protocol for that. We lay that out. We have this 3-year program that basically empowers people to teach and learn and develop, very complex and applicable real world skills. And then we measure educational and wellness outcomes. It's in the early stages. We have, so ultimately, I can't plug too hard because it is tricky with JAGs, the Judge Advocate Generals of the military, and I can't spill the beans too much, but essentially, we're rolling it out. It's looking good. Really strange outcomes are we're having people with no formal training ultimately through these makerspaces building COVID disinfection robots and feeling great about themselves, increasing base morale. And it's a very interesting sort of intervention that we ultimately hope to roll out to the public education system. That would be kind of the next step. And, you know, education is a primary, the K through 12 education system is a primary place for intervention for public health and public health in the mental health space. If you improve education, you improve everything in somebody's lives, and you don't need to worry about side effects. So that's sort of a side thing, and it's kind of rot from, you know, in the same way that I am filled with despair thinking about all the suicide and depression that I grew up around, I am filled with anger and hatred with the amount of poor education that I had to slog through. So in a way, that is the second crusade, and the hope is that ultimately we'll be able to push makerspaces as a way to actually have people have skills that allow them to get jobs and not just fall into destitution or feel really confused or have existential crises as they leave high school. Because while people think, oh, the crisis that people have in their freshman year or whatever in college, or, you know, when they get out of high school and they don't go to college, oh, it's just part, you know, it's something you roll your eyes about, the same way you roll your eyes about puberty. It is an important inflection point in mental health. It is a place where a lot of early adult mental health issues start arising. Early onset psychosis, depression, bipolar, it's all in that critical stress area. And one of the major stressors that you will always see in the clinic, especially among the suicidal, is you always have issues with socioeconomic barriers that are just keeping people down. So in a way, this is kind of addressing that from another side. So that's makeLAB, and yeah, ultimately two very strange projects, makerspaces and cough syrup. But ultimately, the plan is let's make things better, because the current standards are dismal. They're dismal, and we now have evidence and data and science, and they're showing the way. They're pointing the way. There's no need to reinvent. Well, it's not. Maybe we may need to reinvent the wheel, but at least we have the data to show that it's probably going to work.
Yeah, absolutely. Really fascinating stuff, Mike. And it's, as I said, wishing you the best with all this moving it forward. For everybody that's listening to this episode on the podcast, there's going to be watching on the YouTube channel. You've been listening to Mike Wang, neuropsychiatric researcher, adjunct teacher in facility, neurosciences at Johns Hopkins, also on the board of makeLAB, doing really amazing things at the intersection of neurosciences, the immune system, psychiatry, education. Mike, it's as I said, and it's a fascinating portfolio. Wishing you the best with it. I want to thank you for taking the time to come on the show and talk to us for a little while. Thank you for everything you're doing with it. And as we usually say on the show, thank you for helping to create a better tomorrow through your initiatives. It's really very inspiring stuff. And
absolutely, it's been a privilege.
Great seeing you.
All right, cool. Thank you.